In the previous video, you saw me explaining how to play this Monty Hall game, this Cars and Goats game, using the switch strategy. In this video, we're going to go through the second half of Exploration P.3, which discusses that switch strategy and the probability of winning using that switch strategy. So, we're at problem number 9 in Exploration P.3. We're going to play this switch strategy 15 times and record, did we win the goat or did we win the car in each of those 15 games. Now again, if we were in a regular face-to-face classroom, I'd ask you to actually play this switch strategy with a partner where one of you is the dealer and one of you is playing the game, and you'd play the game 15 times and record whether you got the car or the goat. Since this is just a video for the online course, I'm going to go ahead and give you the results when I observe this happening in my classroom with a pair of students. All right, here's the results of the Cars and Goats game playing with the switch strategy. A pair of students doing this 15 times in a row. So for example, on the first game that they played, they'd used the switch strategy and won the car. On the second game they played, they won the car again, and so forth. Looks like on the fourth game, they lost and got a goat. So it asks in problem 10, what proportion of the 15 games did they win the car? So it looks like in this example, they won 11 of the games out of 15 attempts. So that's 11/15ths of the games are won, which is 0.733 as a decimal, or 73.3% of the games. We're trying to understand that probability is a long-run proportion of times that success would occur. So 15 is not necessarily a long-run proportion. We'd like to play the game maybe 1,000 times, 10,000 times, and try to understand what proportion of the times was the car won in the long run. So again, we can use this simulator, this computer simulator, to try to answer that question. I'm going to go back to our Monty Hall simulator online. This time, instead of using the keep strategy on the left side, we're going to choose this, what they call change strategy on the right side. So we're going to use this switch strategy, change strategy, where they pick the door, and then when the dealer asks them, do you want to switch to one of the remaining 2 doors? After they've removed one of the options, they say yes. So they switch to the new door and see if they won with their switch strategy. Problem 11 and 12 in your exploration ask us to do this 1,000 times. So in the simulator, I'm going to up this to 1,000 tries, and I'm going to use the change strategy, the switch strategy, and ask it to go ahead and tell me how many times it wins with the switch strategy and how many times it loses with the switch strategy. So I hit start, it's going. It's playing and playing and playing, every time using the switch strategy. Again, if you haven't seen that, be sure to take a look at that video to really understand what that switch strategy looks like. Okay, it says here, he played 1,000 times. Looks like it was 693 cars won in 1,000 games. So 693 cars won in 1,000 games. So that's really 69.3%, which leaves 307 times that it lost using the switch strategy. So that's 30.7% of the games lost. Now recall, back when we were playing with the stay strategy, just pick a door and stick with it, and that's the door you pick. When we played 1,000 games back there, we only won the car 32% of those 1,000 games. So 32%, which leaves 68% of the time that you lost with the stay strategy. It's almost as if these two things reversed, right? Instead of 68% losses, we now have almost about 68% wins with this switch strategy. So number 12 asks, based on the 1,000 simulated repetitions of the game, what's your estimate for the probability of winning the game with the switch strategy? So it seems like the estimate is about 69% of the time that you would win. How could we use simulation to better estimate this probability? We could play more games, maybe 10,000 or 100,000 times, and see what the probability of success is, the probability of winning the car is if we play more and more and more games. Remember, probability is the percent of times that you win in the long run. So at this time, I'm going to actually tell you the actual answer for the switch strategy and what the probability actually is. The probability of actually winning with the switch strategy is 2/3. If you kept playing and playing and playing over and over and over, the probability of winning would get closer and closer and closer to 2/3 of the time that you won. Why does that make sense in theory? It makes sense in theory because the only way you can lose with the switch strategy is if you originally picked the car and then you were forced to switch because you're using the switch strategy.